Good morning, everyone. Thank you for coming with us here today. And thanks, Ellen, for that good introduction for everything. So I'm going to give you an overview and then move into some hands-on pieces for getting people set up and working with some of these example tools to work with the data. So very quickly, I'm not going to go through all these points, but the key things you can see when you think about, all this assembled together infrastructure and services, it takes a lot to bring it all into coordination and make it actually work. So if you want to work with the data, you want to do this analysis with it, let alone work on it within the context of an international collaboration to help conduct health research. So there's the computing part, but then there's also all the different specifics that you need to take care of, from the software, the infrastructure, hardware, making sure that you collect the data, you organize it, you store it, you make sure it's validated, make sure it's harmonized, and then be able to launch and process tasks with it, and then go through and then, once you're done calculating things and doing some analysis, you want to be able to share it with your colleagues and peers. And then, of course, there's the more, fun things, including such as finding funding and so on. But all of this is required to bring together that, that community of activity. So, but we're going to focus on the technology parts, and the technology parts really starts with the very beginning, right? How do you collect your data, right? And so there's different modalities that you're going to be collecting. In this case, we'll obviously focusing on one or two here, but the end, regardless of the modality, you want to be able to have a common mechanism by which you can actually then store and organize that data. And what was mentioned previously by Alan was the LORIS platform for doing that multimodal data collection and management. And that covers both, across the spectrum, covering imaging, the genetic, epigenetic, the phenotypic pieces, the behavioral, all the way through to the biospecimens that are in the system, and of course the electrophysiology data, which is of particular relevance in our conversation today. So starting with the collection part, you need to be able to capture that. And what LORIS is able to do is provide that capture capability by particularly grabbing the data and ingesting the data from the different sources, but then organizing it according to standards. Particularly in the case here, people might be already familiar with the BED standard. So once you go from the capture phase, though, you have to make sure it is validated. So there's already tools within LORIS to make sure that the data has been validated. It gives the ability for the team collecting the data and to go through and validate, but also to annotate it. And there's a built-in web-based visualizer, so there's no necessity to download the data that was collected. You can do it all through the web interface. And then, of course, this is all stored on the back end through a structured database system that really has a nice variety of hundreds of powerful components to it, but the real focus that I want to point out today is really the emphasis is to be able to query that data, to create cohorts of interest based upon different parameters that you might be able to set. If you want to then do certain searches as a user, you're able to do that with the data query tool. And ultimately, this is all back-ended onto what we call a data provider. And the key real element that this provides is the ability to link this to high-performance computing, the CBRAIN portion. There's additional plugins that LORIS provides, not only for connections, obviously, to CBRAIN for the big data processing part, but then you can also then connect that into other repositories for metadata, so for broader visibility of that data to other spaces, as well as for publishing, whether it's things like the NIH, open journals online, such as NeuroLibre, for example. So to shift, going back from that last piece, where, of course, connecting to the CBRAIN part, you say, okay, how do you have choices in terms of actually how you analyze your data. You can say, okay, great, whether it's functional imaging, structural imaging of the brain, you can say, well, how do I work with this? You can say, regardless, my outcomes that I like to work with and achieve are, you want to be able to make it easy to work with that data. You want to make it reproducible, be able to scale it up, not just for one subject or a handful. Literally, sometimes in some data banks, they're talking about thousands of participants and subjects. And you want to be able to collaborate and share it. And it's not it's not just an or solution. Of course, there's different options. I think a lot of people are familiar with the command line option, but there's risks and rewards with going different directions. With the direct command line approach, of course, there's risks associated with how do you manage and tabulate the information? How do you build the record keeping in between all the components that go from end to end between data, processing, and output? But then there's also simplicity in terms of we want to lower the bar to entry so that the scientists can focus directly on the scientific element and leave the bulletproof or hardened computing portion to a platform that is able to support that workflow, which is CBRAIN. So I'm going to bring you through some of those cases today. And what CBRAIN is able to really do is to allow you to shift from that command line-based approach, even though we have some APIs for, I would say, more power users for specific needs, but it shifts it from using the command line to a web-based interface where you can then easily migrate and run your applications on the high-performance computing side of things and letting CBRAIN do the orchestration of all the steps for you. And that can apply not only for things like, it's not advancing. Yes, so to go from, and it's multimodal, particularly in its approach. It applies the CBRAIN's case to any different particular domain. It's domain agnostic. It can also apply directly to heart imaging, which is what we're also doing now with some colleagues in Ottawa. It can apply to single-cell transcriptomics in terms of the way the tools work. And also particularly, as you'll see today, it applies in terms of analysis of EEG. I won't go into depth of the details of this, other than to say that the real core of what CBRAIN is able to do is based upon the fact that it is doing the orchestration using containers. So the reproducibility part is by having packaged applications that are then really portable and movable across the system. And then we also have something called boutique descriptors, which basically then are descriptions of the parameters going to be used for the analysis of the objects of interest. And what CBRAIN is able to do is provides the web interface, which you see at the top, bridges it in between through a series of services to a distributed network of compute and storage. So it can be a federated global enterprise that is connected in using CBRAIN, but that's really masked away through the interface to make it as easy to use as possible. As just pointed out already by Alan, we have over 1,700 users, 32 different countries, and it's connected to a wide range of computing resources, both nationally and internationally. And that user community continues to grow, again, 1,700. And you can see the proportion here. It's even though its origins in Canada, it's really grown to be international in scope. The tool space continues to grow. These are all containerized tools. So these are extremely portable. Based upon the containerization, we can look at whether it's fMRI, pre-processing, analysis, structural MRI, genetics, the EEG, particularly of interest, conversion tools for different formats. That way you don't have to worry about downloading the software yourself, trying to compile the software. You don't know what flags and options are used. All that is directly embedded by building the container that we have within CBRAIN. And tying that together, of course, the tools is also the large scale, the data pieces. And just to highlight, just some of the data banks that are connected in. And the benefit of being tied into the data banks as they are is that we avoid a lot of unnecessary duplication of data. So these are single points. Of course, you can configure multiple points. But these are points that allow people to draw from the same sources, but without having duplication of data. And just most recently, CBRAIN is connected into all the Open Neuro infrastructure. So any of the data sets that are in Open Neuro, you can see on the bottom right, there's a analyzer view in CBRAIN button that's there now. So I showed before the different modalities of collection and capture and then storing of the data. CBRAIN fits into that space, same process as part of the endpoint, where then the user can work with that data as captured by the LORIS side of things. But in this case, we're going to be talking in the context of EEGNet, which my colleague Christine will talk about later on today. So within working with that data space, the user is able to identify the data of interest that they are interested in analyzing, select it from the cohort of tools, which my other colleague, Jorge, will be able to go through in some hands-on components and show you how to run that in CBRAIN. Process it on any array of distributed connected systems, and then save those results back for collaborating with your colleagues in your groups. Just a very quick snapshot of some of the features. Again, just to show you, you'll see some of this when you go through the exercises, but it really presents a web-based interface where you can not only work with your files, thankfully it's a large screen here, you can see your files, and then working with those files, we also have built-in visualizers, both for things like the volumetric and surface viewing, but then we also see for the QEEG, the EEG part, there's also built-in visualizers for that as well. And then not only from the file viewing, you actually then can monitor very easily through the web interface some of the tasks, and I'll walk you through some of those pieces as well. Same thing with the outputs. Again, the visualization, there's a lot of provenance information, so you can know exactly you started with some data, you know the tool, then you applied it to, and the output. And you can then do all this through the web, go back, you can work on some activities, come back a few months later when you're trying to revisit where you were at before. All that information is persistently stored and visible, so you can then make that connection and resume where you were working. And this is just shows you the range of data that can be stored in the system. That was my hand in January of this year. Very quickly, again, for our more power users, we have an API interface. So we have a large number of projects that are also using the API layer. So rather than going through an individual clicking activities, they're able to also programmatically use the CBRAIN interface to build their orchestrated workflows, which just makes it very powerful for all the components that CBRAIN provides. And then you can do that fancy things such as using it within Jupyter Notebooks, for example. So these are examples of notebooks where the data has been inside CBRAIN, used within a notebook context for things such as NiLearn in this particular example. So I think this is just a quick overview, and we'll get into the practical hands-on pieces of getting set up shortly, but really just show that from the big data point of view to do the analysis and the computations, really you need infrastructure and services. And the idea behind CBRAIN and LORIS are two core services that people can use then to manage and collect their data, but also to analyze it. And particularly in the case of CBRAIN, which is more my emphasis, it's a very general platform. It can apply to domain areas even beyond brain science. And really together, are providing a venue for integration and interoperability across the system. So I invite you to, if you have any questions after, obviously we're here all day. These are all listed in the information packets. So we'll move on to the hands-on part. Just by maybe a quick show of hands, who here has, when at the very back we had a little sign-up sheet in terms of accounts. Is there anybody who's signed up for an account? 2? Magic tabulation, it feels like I'm running a lottery or playing bingo. Okay, so this is easy to do. So if you're not quite signed in yet, we can have time before some of the afternoon exercise or the exercise that come on to get you set up so that you'll be able to proceed with what my colleagues will be showing you. So the part, I'm just going to kind of walk you through step by step, and these are again all in the handout sheets. It's just getting you started. What we did for the purpose of the workshop is just created general accounts that people can use, but you can go after the fact and create an account for your own, say persistent use. So for the accounts here, when you go back and later sign up, put your email on the list, and what we'll do is assign that email to one of the accounts, and all you'll have to do then is once you have that assigned is click on forget your password, but you just please remember your account name. It'll be OHBM followed by the series of 3 digits. Just remember that part. And then when you click forget your password, it'll then trigger a web page that'll bring you to say you punch in just the name to login, the email address, and it just does a verification. That way it doesn't send it to an incorrect address, and it'll check, and then you'll receive a link in your email that'll give you a temporary password. From there, you can reset it to something of your choosing, okay? And the purpose of this, we just want to make sure you have very easy access to the data through the examples that we wanted to take you through today, okay? And the QR code that's on the back sheet will also bring you to the portal entry. So once you go back there, you'll be able to log in with the OHBM account that was specific to your selection, and then with the new password that you would set on the system. So that'll work smoothly there. It'll ask you for a new one, and then once you be connected, and then you'll be brought to basically the portal, the dashboard entry. So this is really I would say the first point of view that you'll see in the system for the CBRAIN side. What we do generally is provide updates of general news information if there's any changes to the system in terms of new data sets available. You can see that on information on the left-hand side. There'll be other pieces that show you what projects by default you're a part of. So what these projects mean is all the open data sets that are visible to all users of the platform. So things like, for example, anything that's configured on the Canadian Open Neuroscience platform, that will all be visible in the list that's shown here. It'll also show any of the already existingly configured open neuro data sets that are available in CBRAIN, for example, as well as a listing of the available software containerized applications within the environment. So what I'm just going to walk you through now is what, as a prelude to what you'll be exercising with the scientific tools that we'll be hearing about coming up later. What do you do when you first get started? So you'll go from the top. I'm just going to go back to the dashboard view here. So at the very top of the dashboard, you'll be seeing a category called projects. This will bring you to, because there's potentially so many projects that you can be part of, the projects has been organized into 3 different categories. Once it moves forward. Oops, helps if I point the right button. So your private projects by something that you just work on by yourself, so that's your choosing, but then you can also see ones called projects shared with me immediately to the right of that. For the workshop, we have projects shared with me. In this case, it was only one at a time, but you'll see multiple ones there today with the different input data sets that my colleague will walk you through as input data sets for the tools that you'll be exercising. But for a good practice to get familiar with the environment is to create your own project, because this is something that you'll be wanting to collaborate with your colleagues, just distinguish for your particular research activity. So when you can easily create a new project, you just put in a name. In my case, I just named it with the user account that I was having, my AG project for the workshop. Any text that you want to name it can be and create. And then you'll see that is now added to your list of private projects. And you can invite people to even join those later on. So as part of your experience with CBRAIN, you can build those, like I said, that network of collaboration across it. And you can see in there, like I said, during the part, you'll go to the project shared with me. Here I've just shown one, but you'll see about 3 other different projects. One will correspond to the different, like I said, input data sets that my colleague Jorge will be carrying through. In my case, what I want you to do is just to get familiar with the fact that CBRAIN will let you work with the files, the projects, but then also the tasks to analyze. So what I want to show you here is just an example of how to work with the files. So if I go into that one particular project that I showed here, the OHBM 24 project, in this case, I put a file in there. It's just an imaging file, a structural imaging file. That was the top screen that you'll be looking at there. If I want to actually then look at the content, this is going to show you now working within the file. If I click on the structural .ni file on the left side, I can then get directly within my browser. You don't have to download it to your local computer. You don't have to then move it around. Directly within the web browser, you get access to information about the file, when it was created, what projects it's part of, its size, and then even below that, you'll have an embedded visualization tool based on Brane browser within CBRAIN that'll let you traverse the different layers, and you can actually then view that directly within your browser and change it to, and adjust different thresholds and so on. So that's all directly within the CBRAIN side. So that makes it very easy in terms of examining visually the file, for example. But if you want to do any processing with it, part of the different framework that you're going to use is you're going to want to then be able to launch tasks. So what you do for that, as an example, all we want to do, say in this case, is run this structural imaging file through one of the FSL tools. You'll see more relevant tools coming up. This is one that was nice and quick. So you do the little checkbox beside the file, and you say, that's the one I'm interested in using. You go up to the top, and you'll see on the top left there's a launch button. Selecting the launch button then brings you to a menu where you select the tools. And we have it all categorized between either the different modality types, or if you know the tool that you're interested in, we have a search box where you can type in the name of that particular file or that particular tool. In this case, I started typing FSL, and I started creating a completed list. So I selected FSL BET. Clicking on that lets you then choose where you would like to run that tool, and it provides a variety of systems that have the tool configured and available for use as the user of CBRAIN. Because this is a very fast tool, this was very good for things like workshops, so I selected it for one of our servers called Converter2, and that's the same one that you would be using in part of the exercises later today. By doing that and selecting launch, you get to 2 menus, one that lets you control how the task will be worked through the system. So you can see at the very top here, the task controller shows you exactly the version. You see the version of the FSL tool that you're using. It shows you 2 options. You set where you want the data to be stored and output. So you can see in the project category, I selected the name of the project that I created, right? It's just the way I can decide to organize things and keep it structured. And then you can give it a description to facilitate, so you can say, oh, this is what I was doing for the workshop or something like that. So that's the CBRAIN orchestration layer. But below that, what we do, and rather than having everything that you would normally see on the command line, where you can maybe mistype, put a dash instead of a double dash or underscore, you can make lots of typing mistakes. All the input parameter spaces defined for the tool are mapped then to the web visible page that you're going to be setting. So all the options are basically either available through drop-down menus, where you would say, in this case, select the input file as the structural.ni. And then if there's any parameters to adjust, you can actually then select, depending on the tool, you'll see a variety of options that you adjust the tool values parameters, and the ones that are mandatory will be marked as mandatory, which ones are optional will be marked to be clearly visible, which ones to change. So it makes it much more structured and then capable for record-keeping purposes. So in this case, it's like I said, very simple. You click Start FSL Bet, and then it switches you then over your task view in CBRAIN. So you have file views and task views. And then with this exercise, you're launching the task. You can see the green bar at the very top. It says it launched it in the background. And then you're able to then watch the status of your tasks through the system. So with the bottom image, what I just did was switch to my project that I created, so the OHBM 001 EEG. It's going to switch to my task list then. So I can see in the top image, that's the one I just submitted. So you can see that goes through a cycle of states, queued to running, and eventually what you'll see is in the very bottom, a nice green column completed for the task. So that we have this nice view of visibility, and you can watch the state change depending on your application. Of course, this one was very quick. Other ones, of course, could be longer running, depending on, but you can watch again that cycle of processing. You can then look at the output of your task, which is another thing. So you're able to view the input directly in CBRAIN. You can then also look at the output just by clicking on the task name on the left-hand side. You're then provided information that you would normally see just in a log file, and you'd have to keep track of where that log file is on the system. This is all tracked internally within CBRAIN and presented through this file view. So you get links that let you show you the tool name, which version, where it was run, when was it run, and then you can see from nice options at the very top. It lets you do things like, okay, well, I want to resubmit this because I maybe want to resubmit it with a different version that might have come out for the tool. You can then resubmit the task, same parameters, with a different version. So it makes it reproducible and rerunning it again very easily. And then you can see in the other information, it produces a list of all the inputs, so you know exactly what inputs you were processing, what the parameters were, and you can see exactly everything there that you would normally then hopefully be able to try and track through some other difficult means. Again, and directly linking from that is the output. So you can visibly look at the generated output, or again, directly in your browser without needing to download it. You can see all that information directly that way. Let me just go back. So again, this particularly just really to emphasize, I'd say that part, linking between input, tool, and output, that saves a lot of headaches, a lot of trouble in terms of keeping record of that activity, particularly when you're dealing with hundreds potentially of participant subjects that you're working with. It makes it much easier, and then you can, as I said, work with your colleagues to have that a much more reproducible system where you're not worried about the individual complexities of the systems to which CBRAIN can connect. That's it for my portion. I didn't quite check at the time, unfortunately. Are there any questions? I know this was rather rapid, but like I said, I'm here. We're able to help people get on board into the system throughout the session and carry people through that.